Okay, once again, good morning. I'm Daniel Pittman.
Brian.
I'm Shannon.
I'm Seema.
And we work with our mentors, Brian Ellerback and Brian Filmar with Rinker Design Associates. So our project is located in beautiful Northern Virginia. It's in Loudoun County, right next to Dulles Airport. So if you see a flying right here, we'll go into our site, which is a warehouse distribution plant. So the whole idea of this warehouse is to get as many trucks in and as possible as efficiently as possible. So some background on the site, 17.15 acres. There are no wetlands on the site. However, there is a stream that runs along the southern boundary of the site. So that was something that we will need to protect in our erosion sediment control measures. The zoning of the site is planned development industrial park. So this gives us a by right use of the land. And in addition to that, because of the rapid growth of Loudoun County over the past decade, they explicitly call for the want and desire to have an industrial park in the vicinity of Dulles Airport. So if you look around, there already kind of is one, and we're just merely adding to it as another plant. The site's already served by existing water and sewer utilities, and there is one single access which will remain onto the site.
Alright, this was the first layout that we came up with. We ultimately did not select this, mostly due to the awkward placement of the rectangular building on the non-rectangular site. And we felt we could maximize the square footage per the goal of our client. This is the layout we went with. It has a slightly more unconventional shape to it. And then this is the final design. It added a second basin. It's able to have 197 square foot of warehouse space. And it has an aesthetically pleasing entrance right by the one entrance over on the western side. And it really just maximizes the building, which was the main goal of our client.
The road is designed to allow for fire trucks and emergency personnel to access all around the site. We did increase the width of the road to allow better truck access from the entrance to the truck loading docks. There are 134 parking spaces available for passenger vehicles. There are 51 bays along the back of the building, and as well as 36 additional parking spaces for tractor trucks. Grading is fairly flat for this site, so most of the road is only about just over 1% of the slope. That allows us to drain to several inlets placed around the site. Most of the site is greater than 3 to 1, but it does get around 3 to 1 slope near the bases.
Alright, so in developing our pre-development, we had to find the peak flow. We had to divide it into two sub-areas, and then we picked two critical points where we could run analyses on how the water was leaving our site at these points. We chose these two areas based on how the water would naturally flow in the pre-development site. And you can see there in the corner the peak flows found. So then in our post-development, there was more of a challenge on how to divide up the roof, because we could direct the water flow into either Basin 2 or Basin 1. We decided to divide it about 3/4 of the roof to one basin and the rest to the other. You can see the delineation of the two watersheds. And again, the chart shows the pre- and post-development peak flows for both 2 and 10 year, and we found these using the rational method. And then using the 10-year peak flow development, we had to return post-development to the peak flow, and there's quite a difference, as you can see in the high graph here. And using TR55 rationale, we sized the volume of storage needed, and we came up with we needed 2 acre-feet of detention storage, and this is how we sized our basins.
The structure system that leads those basins is indicated here in blue. There's 23 inlets throughout the site located at all the low points, and 7 roof drains that collect water and send it straight to the system underneath the ground. The structure network was sized using the rational method. The minimum velocity came out to be 3.75 feet per second with about a 0.5% slope.
Water lines are mandated by the Loudoun Water engineering design manual. As you can see, it's 3,000 gallons per minute water flow. site already. It's a matter of extending the 8-inch diameter ductile pipe around the site. The sewer system was based on 144 people at 100 gallons per day, which is very conservative, and it connects directly from the building to the existing connection. The water line does pass over top of the sanitary sewer, but by several feet. There are air release valves located at the higher point here north, as well as a bullet valve to the south.
Okay, so as I mentioned earlier, we needed to protect the stream that flows along the southern boundary of the site. So first thing we decided to do was basically surround the site with silt fence. And yeah, it's not very effective with backup, but it's mostly just to keep people off the site. When the silt fence would go perpendicular to the contours, we replaced it with a chain link fence. So our main methods of erosion sediment control was to use diversion dikes. If you look along the southern boundary of the site, you'll see one long diversion dike that nearly crosses the whole site and sends it into our sediment basin. If you look towards the middle of the site, you'll see there's a natural ridge, as we said before, and right here it channelizes the water right into our construction entrance, where that was existing and that was the way it was. So to get around that issue, we used another diversion dike and send the water into a sediment trap. From there, the water will flow out of the sediment trap into a proposed culvert, which goes beneath our construction entrance. And finally, it gets diked again down into our sediment basin. On our phase 2, once the gradient is stabilized, we mostly used inlet protection. And our basin 1, again, is converted from sediment basin into a full-time stormwater protection basin.
Okay, the total cost of the project came up to be about $2 million. There's a few things that we can do to make this project a little more economically feasible. One of which is to raise the base elevation of the building 1 foot to an elevation of 278 feet. This will reduce excavation costs. Another thing that we can do is reduce the number of parking spaces as well as minimize the length and width of the sidewalks. In total, all these changes would bring about $200,000, would decrease the total price about $200,000. Those are the recommendations for our site. We'll open the floor for any questions.
I don't have a question, but I just like to comment that I really like your graphics. I like the way that you put stuff to the back that wasn't important and you brought the important stuff up to the front. You did a nice job with that.
Thanks.
Right.
Yeah, I'll comment about the grading as well. The site does, the floor elevation does sit at 177, but the truck loading docks sit at 173, 4 feet drop. And the building does slope, or the grade does slope away from the building a half a foot for the first 10 feet, except for the loading docks, which only slopes 2% to allow for the trucks to back up and be fairly flat to allow forklifts and whatnot to